Okay, so movie number 2, I got kicked out of my classroom, as you might have heard, but we're gonna determine why we get these strange curves with the sine. So if we go in the positive direction, it's going to be a mirror image of what the negative direction looks like. Notice we start at 0, 0. That's just the nature of the sine curve. And we're just going to stick with degrees for now. We're not going to talk about radians until a little later. So we're just going to stick with degrees to prevent this from becoming too confusing too fast. So we're going to go to 90 degrees, and we're at 90 degrees, we're at 1. At 180 degrees, we're at 0, 0. At 270, 360, we're back again. And this is going to keep oscillating through eternity. Think about it. At 720, you're going to be back at 0, 0. Or at 0. Okay? And then, so it's just going to keep repeating every 360. And if we go in the other direction, the negative direction, we begin to understand what's really happening with this. Put in some reference angles to get this curve to be a little bit more detailed, and you're going to begin understanding why we spent all that time learning about special right triangles. The reasons anyway. There are a lot of reasons why they're important. So if you go from the hypotenuse to the shortest leg, which is the one opposite 30, we get 1/2. Okay, so we can start filling this in. Remember, 45 is the square root of 2 over 2. You remember that one, right? Our hypotenuse is 1, and what you multiply when you go to the hypotenuse from a leg, now we're going to divide, but you always rationalize your denominator. Okay, so we get 1 over square root of 2, which is equal to square root of 2 over 2. Oops. But we're going to convert it to decimals because that's really the only way to graph it. Don't forget, now when we go from the shortest leg to the longer leg, we multiply by the square root of 3. Sorry, it's getting a little messy, but again, I'm going to put it in a decimal. And at 120, it's perfectly symmetrical with 60. So it actually makes a 60-degree angle with the x-axis. So it's the same value as 60. Sorry, I'm having an issue here. I'm not redoing this movie. Go away. All right. Now with the reference angles, we can get a more detailed representation of what this curve should actually look like. So at 30, I'm at 0.5. That's not quite 0.5, it's a little higher. So, okay. And then 45, we're at 0. What was it, 71? So we're a little higher And then at 60, we're at 0.86. And then we come back down. And we're going to follow that pattern in both the positive and the negative direction. Oops. Actually, I'm going to redo both of those. And it's going to continue. So I can keep doing these angles all day, but I don't want to, for one. And for two, we can now predict what this is going to do through eternity in both the positive and the negative direction. It's kind of fascinating to me. And it all has to do with the ratio of the opposite to the hypotenuse. So I'm going to draw it in. Continue on and continue making that pattern in both directions.